Hey, welcome back to your favorite pre-calculus class. We're going to take a look at systems of nonlinear equations now. Here's our objectives for this lesson here. So if we're thinking about the first one here, we've got the first equation, we've got a linear equation, right? That's y equals 2x plus 4. You know, if we were to graph that, you got some line, right? Y equals 2x plus 4. And then the other one, 2x squared minus y equals 0. So we've got a quadratic, y equals 2x squared. I know I'm not drawing these perfectly, but if you were to graph these things, you'd see, oh, we've got likely two solutions on this thing. Let's think about doing that algebraically then. I'm going to do this by substitution. So what I'm going to do is I'm going to take that linear, 2x minus y equals negative 4. I'm going to solve for y. So y equals 2x plus 4. And then I'm going to substitute that in that 2x plus 4 in for y into that other equation. So 2x squared into the quadratic minus y equals 0. So we have 2x squared minus y, again y is 2x plus 4 from that linear equation, equals 0. So we have 2x squared minus 2x minus 4 equals 0. If I take a 2 out, I've got x squared minus x minus 2 equals 0. Or if I factor that, we've got x being 2 or x being negative 1, right? So we know if x is 2, so if x is 2, let's put that into our linear equation, y equals, the first equation, y equals 2x plus 4, or 2x minus y equals negative 4, whichever one you want to use. Let's plug that 2 value in. So it looks like y equals 2, whoops, that's a plus right there. We got 4 plus 4, we got 8. So we have, if the input's 2, the output's 8, 2, 8. And I would want to make sure that that is also on our quadratic, right? Make sure it's on the quadratic. Check 2, 8 into our quadratic. And then if the other option is if x is negative 1. So if x is negative 1, well, where would that point be on our linear? It looks like we've got negative 2 plus 4, we got 2, so we got negative 1, 2 is that other point right there. And again, make sure you double check those. And your quadratics is always good form. Here's a little bit better picture of that. There's our negative 1, 2, there's our 2, 8 right there. And there's our process, okay? There's our points. We'll better look at that. All right, let's look at another one now. Where we've got a circle, x squared plus y squared equals 4, and then we've got this parabola, okay? So if you were to punch this into Desmos, x squared plus y squared equals 4, you've got the circle with a radius of 2, and then you've got this, I know this is not to scale, but then you've got this parabola that opens up to the right, you know, something like this kind of thing. Again, I didn't draw that very well, but if you were to take a look at that on Desmos, and we can afterwards if you'd like, you're going to see, oh, it looks like we got four solutions here, 4xy values that will satisfy both the circle and the parabola. But what we're going to focus on is how do we do this thing algebraically, okay? So I'm going to take the first equation, x squared plus y squared equals 4. I'm going to take the parabola now. Let me write the parabola like this, negative x plus y squared equals 4. And what I'm going to do is I'm going to eliminate the y squared. So let's multiply this by negative 1. So then it becomes x minus y squared equals negative 4. The top stays the same. X squared plus y squared equals 4. And by doing that, we're eliminating our y squared. So now we have x squared plus x, again, those are not like terms, equals 4 minus 4, we got 0. So x squared plus x equals 0. We can factor that. And by the zero product property, x equals 0 or x equals negative 1. So if x equals 0 then, let's go to our parabola y squared minus x equals 4. So y squared minus 0 equals 4. So we've got y squared being 4. Y would be plus or minus 2. So if x is 0, we have 2. If x is 0, we also have negative 2. So 0, 2, 0, negative 2. Again, verify these into your circle. Make sure that they're both on there. You know, they make sure that they're on the circle 0, 2, 0, negative 2. And that's not going to be the answer there. And it's true, they are. So then we can move on. Now what if x is negative 1, right? Now I can go to y squared minus x equals 4. Y squared minus a negative 1 equals 4. So we've got y squared plus 1 equals 4. In other words, y squared equals 3. So y is plus or minus root 3. So I've got, if x is negative 1, I have root 3. If x is negative 1, I have negative root 3. Again, make sure that they satisfy the circle as well, because I've plugged in that x being negative 1 into the parabola. And you'll see that, sure enough, all 4 of those satisfy both equations. Okay, so we have, there's your negative 1 root 3, there's your negative 1, negative root 3. Again, I didn't draw that very good. There's a little better picture of it. 0, 2, 0, negative 2, negative 1, root 3, negative 1, negative root 3. There they are labeled. Okay? All right, let's move on here. Example 3. What about if we have a hyperbola and a parabola? I'm going to use substitution again here. What I'm going to do is I'm looking at this equation 2. I notice that, hey, y squared is x. I can replace that x in right there because that's what y squared is equal to, right? So note that y squared equals x, and it's equation 2, and I'm going to substitute that into step 2, but it's into equation 1. I don't want to mix you up with my labeling here. So x is y squared is x, I'm sorry. If y squared is equal to x, that's what goes in right there. So we got x minus x squared equals 4. In other words, if we get this side equals 0, so we subtract x, add x squared, we have x squared minus x plus 4 equaling 0. Now that does not factor, so I'm going to plug that into the quadratic formula. X equals negative b plus minus square root of b squared minus 4ac all over this 2a. And what you notice here is you've got there's no real solutions. You can't have square root of negative 15, right? That's a complex number there. We got imaginaries. So there's no real solutions here. So this is inconsistent, right? No solutions, no real solutions. No real, I should be more specific, solutions. This is inconsistent. You know, if you were to punch those in to decimals, you're going to see, oh, sure enough, they do not intersect, right? So again, inconsistent, no real solutions there. We have a real number line graph here, right? So none of them show up. Let's move on here, example 4. I'm going to use, the first thing I'm going to do before I start using elimination is I'm going to get rid of this y. Notice, by the way, y cannot be 0 because of that equation. But I'm going to multiply this entire thing by y to get rid of the fraction. Okay, so equation 1 will stay the same. And equation 2 becomes, once I multiply it all through, y squared plus y. Notice it gets rid of that fraction right there, so I have just x minus 2. 0 times y is 0. The reason I did that is so that I could then multiply this bottom equation by negative 1, and I'm going to get rid of my y squared. Okay, so let me multiply this now by negative 1. and this becomes, you know what, I'm going to go down here. So this becomes, equation 2 becomes negative y squared minus y minus x plus 2 equals 0. Equation 1 stays the same, y squared plus y plus x squared minus x minus 2 equals 0. Now notice, that's gone, that's gone. We have x squared. We have negative x minus x, so minus 2x. And then we have negative 2 plus 2. That's gone. So we have x squared minus 2x. And we have 0 plus 0. We get 0. So this is where we're at. X squared minus 2. Oh, come on. Minus 2x equals 0. So we factor that by the zero product property. We have x being 0 or x being 2. Alright? So there's our input options. So now we're going to say, well, if x is 0, similar to that other problem, then let me use this first equation. So if x equals 0, so I'm going to use equation 1, y squared plus y plus x squared minus x minus 2 equals 0. So y squared plus y minus 2 equals 0. So y plus 2, y minus 1, y could be negative 2, y could be 1. So if x is 0, y could be negative 2. If x is 0, y could be 1. All right, so far, and then what I want to do is I want to verify them into equation 2 right here, right? So I plug those in, I check them out. They look good. Once I've checked them, awesome, I'm going to move on. Now, what about if x equals 2? So if x equals 2, into equation 1, y squared plus y plus x squared minus x. So we have y squared plus y plus 4 minus 2 equals 0. Well, 4 minus 2 minus 2, that's gone. So we have y squared plus y, y squared plus y equals 0. Factor that. So y could be 0, y could be negative 1. So if x is 2, y could be 0. And these will satisfy equation 1. If x is 2, y could be negative 1. So then now I check it into, again, make sure they satisfy our other curve there. And notice, remember how we said, well, y cannot be 0. So that's out. There's no way that'll satisfy the other one. And then you plug in the 2, negative 1. You make sure it works. Sure enough, it does. 1, 2, 3 ordered pairs are the solutions for that one. Okay? And you can throw them on to Desmos as well and take a look at that if you'd like to. And remember, and again, remember, y cannot be 0, right? Denominator there. All right, our last one here, example 5. I'm going to take this first linear, and I'm going to solve this by substituting. So I'm going to solve for y with equation 2. So let me take equation 2, 2x plus 3y equals 5. I'm going to solve for y. And I'm going to substitute into equation 1. 4x squared minus 3xy plus 9y squared equals 15. Again, I'm going to plug y in right there for that y, and right there where it's going to be squared. Okay, so we have 4x squared minus 3x, y is going to go in, plus 9, y is going to go in, and squared equals 15. All right. So what we have here, 4x squared, and I'm going to distribute that. I got plus 2x squared. I got minus 15x over 3, so minus 5x plus 9. Now remember, this got to be expanded. There's two of these. Okay, so first outer, inner last. So we've got 4x squared plus 2x squared minus 5x plus 9 times, looks like that'll be what, 4/9 x squared minus 10/9 minus another 10/9 x, so minus 20/9 x, that's the outer and the inner, and then 5/3 times 5/3, we got 25/9 equals 15. Now I'm going to distribute the 9. So we got 4x squared plus 2x squared minus 5x plus 4x squared minus 20x plus 25 equals 15. 4x squared, 2x squared, 4x squared, I got 10x squared. Negative 5x minus 20x, I got negative 25x. I got, I'm going to subtract this 15, so I got plus 10 equals 0. Let me take that up here, and let me take a 5 out, so I have 2x squared, come on, there we go, minus 5x plus 2 equals 0. Go ahead and factor that. Let's see, that'll be 2x, x, 1, 2, minus, there we go, so minus 1, minus 2 on that. So 2x minus 1 equals 0, x minus 2 equals 0, so we got x could be 2, x could be a half. Alright? So, now that I know x could be a half, so if x is a half, I'm going to use this equation 2, 2x plus 3y equals 5, or maybe I'll just use it where it's solved for y already, negative 2/3 x plus 5/3. So negative 2/3 times a half plus 5/3. I've got negative 1/3 plus 5/3. I got 4/3. So if x is 1/2, y is 4/3. I go ahead and check that into this curve here, equation 1. Make sure it satisfies it. It does. Okay. And then if x equals 2, put 2 in. So we got negative 4/3 plus 5/3, we got 1/3. So I got 2 comma 1/3. Again, make sure it satisfies that as well, and it does. So we've got the two solutions there. Okay, that's how you're going to solve systems of nonlinear equations. And after you've done the algebra, feel free to also check that with Desmos. Thanks so much for listening. We'll see you guys next time.